Hello, Math 1020 class. This is part 2 of our Test 4 review. I am going to skip some problems because I want to do those with that calculator app on a different video. And number 11 I'm going to skip for now. I'm going to do that on another video, but let's do number 12. Suppose the retail price of an automobile is $23,000 in 1998, and it increases at 6% per year in price. Choose the function that models the retail price of the automobile T years after 1998. And in this problem, we're supposed to use this model. This is the model we use when something is increasing by R% per year. A, in this case, is the initial value of the car, which is $23,000. R is the percent increase in decimal form, which is 0.06. So your final answer should be this. 23,000 times 1.06 to the teeth power. That's part A. Part B, according to the model, what is the retail price of the car in 2016? Well, in part A it says T is the number of years after 1998. So if you're looking for the T value that corresponds to 2016, you just have to subtract 1998 from 2016. And I get 18. So plug in 18 for T. And when you do, you get this number to the nearest dollar. At the end of an advertising campaign, weekly sales amounted to $24,000. That's weekly sales. And then decreased by 4% per week. Write the equation of the exponential function that models the weekly sales. Well, once again, we're going to use something that kind of looks like the model that we used in the previous problem. But the only difference is I'm going to subtract that R instead of adding it. Only because the amount is decreasing every week instead of increasing. But just like the other problem, A is the initial value, R is the percent decrease as a decimal, and we just leave the T in there as a variable. So this should be the answer to part A, in my case. Part B, find the sales 8 weeks after the end of the advertising campaign. So just plug in 8 for T, essentially. Plug that into a calculator, and you should end up with this, $17,313 to the nearest dollar. Number 14 requires a calculator. I'm going to do that on another video, so we'll skip it for now. Well, let's do number 15. Use the equation of the polynomial function to complete the following. State the degree and leading coefficient. Well, remember the degree is the highest power of x. In this case, it's 4. And the leading coefficient is the coefficient of the leading term. And the leading term is the one that has the degree in it. So in this case, -3 is the leading coefficient. Just some basic definitions. Describe the end behavior of the graph of the function, part B. It's enough to just look at the leading term, -3x to the 4th. What does that do as x goes to plus or minus infinity? Well, let's consider what happens when x goes to plus infinity. Imagine plugging a huge positive number in for x. When you do that, -3x to the 4th turns into a huge negative number. So the leading term goes to negative infinity. If you plug in a huge negative number for x, well, the same thing is going to happen, only because when you raise a negative number to an even power, it turns into a positive. And when you multiply that positive number times negative 3, it's still negative infinity. So this function goes down on both ends. So I'm not sure exactly what it looks like, but I know the end behavior of the graph. So in part C, you just have to pick the one that kind of looks like this, and there's only one choice. Let's do number 16. It says that we're supposed to graph this function on that viewing window. So let me input it. And I'll show you what my calculator gives me. It gives me something that looks like this. How many turning points does the graph have? Well, in another video we said that a turning point is essentially just a peak or a valley. This one appears to have 3 turning points. Part C, could the graph have more than 3 turning points? Well, the answer is no, because remember, the degree minus 1 is always the maximum number of turning points. So in this case, 3 is the max, and we've got all of them in our picture. So we can't have any more than 3. We've gotten them all. "17 is another calculator problem. Let's skip it for now. And I believe 18 is also. 19 and 20 I'm also going to skip because those are essentially the 2 problems from section 6.2. They're just calculator problems, and I've already worked those in another video.